Good day, ladies and gentlemen. You're very welcome to today's session, alternative technical session, hosted via the CNPS. Excuse me. So these technical sessions we actually hold every fortnight, and in between we may or may not be in a position to hold more general talks on fundamental questions in physics, mainly from a dissident point of view, but not necessarily. So today we are happy to have a stalwart of the dissident community, Roger Anderton from the UK, and he's got a lot of slides, but he tells me he speaks quickly. His central thesis actually is somewhat different from what many of us might be doing, because we sort of get the basic papers, say the 1905 on the electrodynamics of moving bodies of Einstein, and we analyze it and we criticize it and so on and so forth. But he's looking more fundamentally. He says, well, Einstein's theories, perhaps, of relativity have been rewritten on a number of ways. And actually, he's dating problems back to the translation, or as he would say, mistranslation of the 1905 paper by Sommerfeld and company from German into English. So he says there's a misunderstanding and a mistranslation, and maybe the original paper is different from what we perceive of as the special theory of relativity, and it is given in all the textbooks and is taught at undergraduate level. So he also talks about moving goalposts. You know, they argue one way, and when they're put into one corner, they move things. So I think it's interesting to look at his thesis and maybe obviously look at it from a critical point of view. And we'll have some questions at the end as to whether he thinks that the original theory, for example, was more correct than it's being portrayed as now, or maybe it was always erroneous. But anyway, Roger has quite a number of slides, and he'll be talking a lot on that. Now, what I'm going to do is I'm going to hand over to Roger. And I'm going to project his slides, so he just needs to tell me when he wants to.
Okay. Hi. Hello. I'm working, I hope. So thank you for allowing me to give this talk. I've been studying relativity for a long time, trying to make sense about what's going on. Unfortunately, with Einstein, he doesn't give references to what he's working from. And so that makes studying what the physics is before Einstein difficult to follow. So it's taken a long time to sort out what's going on. So this is what my latest studies have revealed about Einstein's relativity. So can we have the first slide, please? First slide, please, Ian.
By the way, I just put my audio on because this will take a moment. So you think okay. I've just left, but okay. So what I have to do first is I'm going to bring you down.
Okay.
But I need to have you for your audio. So let me see. I'll bring up I'll share my screen first. Share my screen, and then I'll bring the slides up now. Entire screen.
Excellent. Go for it.
I'm sorry. We've done it before. It does work, but it takes a moment to set up.
I can't see what my reflection on the glasses is.
Well, we get rid of that because I'm going to put the PowerPoint slides up now, and I'm going to maximize them. And I can still hear you, Roger, can't I?
Great. Good.
Yeah, perfect.
Thank you. Cheers. Right. So this is the header for the talk. It's called The Rewriting of Einstein's Relativity. So next slide, please. So first of all, I've got to explain about moving goalposts, and basically moving goalposts is making changes to things. And if you look at Einstein's relativity, there's been a lot of changes made to it. And there's not that really much explicit mention that changes are being made to it. And of course, the idea of moving the goalpost is supposed to be a fallacy. But Einstein's relativity is like that. It just keeps having things changed about it. So next slide, please. So this is what Feynman says in one of his lecture series of textbooks. He's talking about relativistic mass, and Feynman's a very famous physicist, and he's supposed to be a genius, and he's got a Nobel Prize and all that. So this is what he teaches about relativity, that relativistic mass is about the most important thing about Einstein's relativity. So let's go on to the next slide, please. But then you've got people now coming out after Feynman, and they're saying there is no relativistic mass. So this is Dr. Lincoln, and he's got a video saying there isn't a relativistic mass. So this is an example of things being changed. Feynman was saying there is relativistic mass, and now later further on you've got people saying there isn't relativistic mass. So I think that's a big change in relativity, to one moment say there is relativistic mass and the next to say there isn't. So in my view, that is moving goalposts. Next slide, please. So people who believe in Einstein's relativity just keep changing things. They're making amendments and so forth, and then just, in my view, moving the goalpost all the time. And if you play a game of sport, the idea is the goalposts are supposed to stay where they are and not move, because if somebody's coming up to score in the goal and the other side's moving the goalpost out of the way, that's sort of like cheating, really. But that's what's happening in Einstein's relativity, just a lot of cheating. They're changing the theory, in my view. Next slide, please. So this is David de Hilse's film he made about Einstein wrong, the miracle year. And David, if you watch the documentary, seems to have thought that he'd proven Einstein's relativity wrong because he talked to an experimental physicist who said there was no such thing as relativistic mass. And I hope I'm remembering that properly. And also, when I was taught relativity decades ago, I was taught about relativistic mass. But relativity now seems to have moved its goalposts and is deciding to go for no relativistic mass. And I think that's, as I've said, cheating. To tell you one thing, and decades later, people who believe in relativity are going to try to change it to something else. Next slide, please. So this is what I found from Physics Today, June 1989, on the concept of mass. And it's a bit small there, so I'm going to do an enlargement of the relevant bit. Next slide, please. So this is the enlarged bit. It's from Einstein to Lincoln Barnett, and Lincoln Barnett was writing a book on relativity, and Einstein wrote basically saying that he himself, Einstein, didn't like the idea of relativistic mass. So relativistic mass is a concept that seems to have been added to relativity, even though Einstein himself didn't like the idea. So Einstein is not in control of his own theory. So one minute people decide we're going to add relativistic mass to Einstein's theory, and next, as I pointed out, Dr. Lincoln is going to say there's no relativistic mass. So it's moving the goalposts in one direction, and that's not good enough. Then he decides to move the goalposts in the opposite direction. And so this is what relativity is. It's just going around in circles, moving goalposts. Next slide, please. So what I've done is I've tried to keep a check of what's being taught at university to physics students And so I went on this course at Oxford, where they were teaching relativity. They called it space-time physics, but it's really relativity. And I complained about the moving goalposts. But the lecturer seemed to think that it was a natural part of science to make changes when new information became available. And so many people think that physics is like that. So making changes to a theory, they think is acceptable. But my complaint about that is they're making changes to the theory of relativity, and they're not explicitly saying that they've made the change, and they're not saying why they've made the change. So it's just making a complete mess of things. And so next slide, please. So I think all this moving goalposts is bad enough, but the physics establishment, is often not pointing out they're making all these changes. And that's not only making a mess of things, but when we are trying to dissent against Einstein's relativity, we're finding that the people who believe in Einstein's relativity are then coming back to us and saying we're not talking about relativity properly. And the problem with that is because they've moved the goalposts. So it's very hard to argue against a theory which has its goalposts moved all the time. Next slide, please. So anyway, after pointing out it's all moving goalposts, I want to point out the surprising thing is that Einstein's relativity had its goalposts moved in the very beginning. Einstein wrote his theory in 1905 in German, and then a lot later they translated it into English. And what they did was they moved the goalposts. The theory that was translated wasn't the original theory. They changed it into a different theory. And they don't appear to have told anybody that's what they've done. They've moved the goalposts. Next slide, please. So in historical terms, it goes like this. 1905, Einstein published his special theory of relativity in German. 1915, Einstein publishes his general relativity, and that's also in German. 1919, Einstein becomes world famous when Anderton supposedly confirms Einstein's general relativity. And then about 1923, Einstein's special relativity paper gets translated from German into English. So that translation is more than 15 years after the paper was originally published. And in those 15 years, more than 15 years, they had changed what they believed was special relativity. So they presented a different theory in the 1920s in the translation to the English speakers than what was published to the German speakers in 1905. And, well, of course, they don't tell anybody that's what they've done. Just a minute. Next slide, please. So other people have noticed that the theory has changed when it was translated into English. And this is one of the people who's noticed, and I think he was in the David de Hilster's film Einstein Wrong, and it was Dr. Edward Dowdy, who sadly passed away now. And he noticed that the theory was different in the German original to what is translated to in the English. And he's a retired NASA scientist and so forth. Next slide, please. So they moved the goalpost, didn't tell anybody. Special relativity, 1905, is a different theory to special relativity in the 1920s. Next slide, please. Am I going fast enough? Yeah. Okay.
I think you're doing fine.
Okay. Thank you. but there are many aspects, parts to relativity. It has its philosophy, its mathematics, etc. And so what I'm talking about is Einstein talking about a different theory in the 1905 German to what is being talked about in English in the 1920s. And that's messed up. Even if the translation problem is sorted out, there are other things about relativity that are messed up as well, such as this mathematics. I'm still complaining about it. Mathematics, it's still messed up. The mess is overwhelming, and you can't deal with it all in this talk. So I'm just concentrating on the translation problem. And the process that the establishment seems to be involved in is just keep piling on one mistake on top of another mistake until they have a mountain of mistakes, as per that cartoon. Poor man is bogged under by a mess of paperwork. And that's what's happened with relativity. It's a mess. It's people have made changes and they haven't bothered to tell anybody that they've made the changes. And surprise, it's happened straight away after in the translation problem. There was a translation, they changed it in the translation. And that is a surprise to me, to some extent, that they would do something like that. I would have thought they would have translated it perfect to what's originally being said, but they didn't. They decided relativity was better understood by changing it a bit. Next slide, please. So this is the usual translation into English of Einstein's 1905 paper on special relativity. And it was, you can see it in that address. And that seemed to be authoritative. It seems to be the one that most people were going by, that translation. If you want to cite Einstein's theory of relativity, then that's the paper everybody goes to. And it's that paper which is a mistranslation, or you can think of it another way, it's been the theory updated from what Einstein was originally saying in 1905. Next slide, please. And so this is what you've got attached to the translation of Einstein's paper. It says this it's added these footnotes. If you read it, it's added footnotes to Einstein's relativity, and that is footnotes that came from Sommerfeld. And in my view, that changes the theory. You've changed the theory by adding those footnotes to it, because that's not what was in the original German. Also, the translation from German into English has been made to try to tie into these footnotes. So you've got it's wrong from two directions. It's been bodged to fit what Sommerfeld thinks the theory should be. Next slide, please. So if I go to this book here, it's a book that it deals with the history of Einstein's relativity. It's by Arthur Miller. He gives his version of the translation of that 1905 paper, and he points out that in this translation, it says about his translation, it differs from and places quite unacceptable English language translations. He's presenting a translation which he thinks is better than the original translation by Sommerfeld and Company. And so Miller was a professor of history and philosophy of science. I think, though, he was looking at relativity or physics more from the perspective of a historian of science. So he was just documenting physics. He was not actually thinking whether the physics is right or wrong or not. He just wants to document what's happening. And so from his view, he's not, he thinks it's not his department to worry whether the theory is being presented incorrectly, and he doesn't, or whether or whether there's physics problems with the translation, mistranslation or mistranslation of the theory. He's not concerned about that. He thinks that's not his department, and it should be the department of the physicists. All he's concerned is the history. And this is one of the another problems with academics. You'd have an academic concentrated on the history of physics, another on the philosophy of physics, another on the theoretical side of physics. They've got all these different departments where they filter how they're thinking about things, and they're not looking at things from a total perspective. So they're only looking at things from a certain point of view. In this case, Arthur Miller is only looking at it from the history. But he is pointing out from the history that he doesn't think the usual translation of Einstein's relativity into English is a very good one. Next slide, please. And so Miller points out that the footnotes in the translation paper come from Sommerfeld, and that these footnotes are not in the original 1905 German. So these are the main footnotes on that. Next slide, please. So I contend that the bad translation to English and the footnotes that were added make the theory different in the English to what it was originally in the German. I can deem the translation as a mistranslation, and it comes from Sommerfeld's perspective. And it's based upon what Sommerfeld believed relativity to be, from Sommerfeld's perspective of what he believed relativity to be. The translation has been adjusted to align with his footnotes and Sommerfeld's perspective. And so if you look on Wikipedia, Sommerfeld was a German theoretical physicist who pioneered developments in atomic and quantum physics. The next slide, please. So what I've got is that Einstein's 1905 paper, published in German, more than 15 years later, translated into English. But in those 15 years, the theory had not stayed static, unchanged. Various people like Sommerfeld had been working on it. And often we are presented with the illusion that Einstein's relativity was solely due to Einstein, but that is false. There were other people working on it. So 15 years later, when it gets translated into English, it's with the bias to what people like Sommerfeld, were now believing relativity to be. And that was different to what Einstein was saying in 1905. And so the question then becomes, why did Einstein allow these other people to change his theory? Next slide, please. And the answer seems to me is that Einstein didn't understand the theory. He was allowing others to modify, change it, because he didn't fully understand the theory. It was a theory in development and not a fully formed and completed theory. And that is my conclusion from trying to read it and make sense of it. Einstein was very flexible, open-minded as to what the theory should be, because he was not presenting a theory that was fully formed. Next slide, please. And that then raises the question, why didn't he understand the theory? And the answer probably is that the theory wasn't his theory. And the likely candidate for where the theory came from was his wife. Or rather, his wife probably should have been mentioned as a collaborator on the theory, but she was uncredited. Next slide, please. So this is Einstein's wife, Milena Marek, as she was studying physics with Einstein at the same time in Zurich Polytechnic. And so the possibility is she's the uncredited contributor to Einstein's relativity paper. Einstein and his wife later fell out, and if she had been a collaborator, then she might have pointed out better understanding of relativity and its difficulties. But she was sort of like written out from the history of physics on this particular thing. As it was, Einstein did not seem to point out the translation difficulties, which may be because he couldn't have been aware of it and had not been a sole contributor to the theory, ? In the male-dominated world of Einstein's era, it might have seemed unnecessary to mention the wife, ? From a modern feminist perspective, the men back then believed they had male privilege, and the term male privilege is a term that they use now, and that would have been a wife could do the work and the husband to take credit for it. Next slide, please. And if you look at what they're saying about Einstein now, I think this is mainly from people who are feminists. They're pointing out that Einstein was a misogynist, and a misogynist is a person who's treating women as second-class citizens. It's a bit like a tier system. You've got the most important people in society would be the men, and they thought they were, and the women were less important, and so it didn't matter that you didn't mention the women, what the women's contributions to things were. And I've looked into this on the latest things on the news. You've got things like Bill Crosby and other people like that, and they seem to be working from a misogynist point of view of things, where they mistreat women and they think they're more privileged because they're men. But sort of society is changing, and these men are getting prosecuted for things like rape. You sort of, I think back in my time, I go out 50 years. I personally wasn't like it, but the men I used to go out, some of the men I used to go out with thought that if a woman comes up to your room and she's drunk, then that means she's saying yes to having sex. But sort of from a feminist point of view now, which has been imposed on society, that is not what the women are doing. So when a woman goes into the man's room and he has sex with her, that is then treated as rape and not consent. But that is a change in society, that the men with working from a male privilege sort of point of view, that they were able to do this to women. And if you look back to Einstein's era, that was probably the common point of view of the men at that time. So that can explain why Einstein's paper on relativity could have been written by Einstein and his wife, but his wife doesn't get credit because male privilege. He doesn't have to bother mentioning the wife. Next slide, please. Next slide. Oh, he's gone to sleep.
Sorry, I have gone to sleep. Actually, you're right.
Next slide, please.
Next one.
Okay, thank you. So it says there at that particular article, it says Einstein is regarded one of history's greatest geniuses, both for his contribution to humanity's understanding of physics, and for his embodiment of the stereotypical traits of the eccentric brainiac, or genius, in other words. But you can read the rest of it. But Einstein's public face, he is an extremely nice person, and his public face. But what goes on behind that in his private life, well, that's not really what's come out, and until recently, and that is he didn't treat his wife very nicely. So he had a very nice public face, but behind that, he had a different side to him. Next slide, please. So this is what I've looked at in the latest news. You have this long-running thing of male privilege, and these people must have been coming from an environment where they believed they had a sort of male privilege to be able to do whatever they liked. And as I point out, this Bill Crosby and Jimmy Savile, before you found out about their darker side, they just seemed to be brilliant entertainers in the public face. But in private, Bill Crosby was drugging and raping women, and Jimmy Savile was molesting children. And so from my perspective, what's happened is that the male privilege has been abused. You had the men thinking they were better than women, male privilege, and then sort of like that position gets abused and they think they can do whatever they like. It's sort of the women as sort of second-class citizens almost is like treating them a bit like slaves. Anyway, next slide, please. So Einstein had a brilliant, a marvelous public face, but a private face that was unpleasant, question mark. Plus, Einstein came from an era before the suffragettes. So the dominant male belief would have been that men have more rights than women. So from that mentality, it might think taking credit for his wife's work meant nothing and was allowed. So it might be the case that physics has been corrupted by male privilege. If his wife had been a big contributor to the theory of relativity, then maybe she could have cleared things up. But instead, she was pushed aside. Next slide, please. And I wanted to go to a video clip here, but this isn't on the on this selection of slides, but you can see the video at that address. It's the real reason you don't understand relativity. Next slide, please.
That video, does it take very long, Roger?
Yeah, it was only a small bit that I wanted to show. If you want to, you can show the whole video. Yeah,
I could do it. I could download that. And it's up to you.
Yeah, go on then. Show the whole video.
Right. Okay. I hope
it saves my voice.
I hope it works. I can't skip video. I'll have to. I don't seem to be able to. I have to go out to the main screen to.
Okay. Thanks.
Be able to. That's it. To get that. Wait. Maybe if I can. I might be wasting time doing this, but.
Okay. It's all right if we don't have time for questions.
Leave it. Can we leave it? Okay, because it will take a few minutes.
Okay, leaving it.
Okay.
Okay.
Don't do it.
Okay, we'll skip that.
Okay, leave it on. Skip it.
Skip that. But you can watch that for yourself later. And what the video clip points out, that Einstein's theory was not a rigid thing. It was something flexible that he kept changing his mind about. And that's the main point that I wanted to raise, that it's not just me that pointing out that Einstein's relativity. He published his theory in 1905, and that's supposed to be his theory. But no, it's not his theory really, in the sense that it's flexible. He's going to change his mind about things. It's a flexible theory. It's not something he's definitely decided upon. And that's suggestive that he should have been saying that he wasn't the sole person that the theory came from. He didn't know the theory properly, so maybe it came from someone else like his wife. So I made a mistake there. It's suggestive he wasn't the sole person that the theory came from. Anyway, the theory was not inflexible. It was not rigid. It kept changing. It was flexible. In other words, it's moving goalposts as a fundamental part of its nature. It's a feature of the theory, that you keep moving the goalpost, you keep changing things. Next slide, please. So Einstein, very flexible in the meaning of the theory, which maybe he would have been, if not the sole contributor to the theory, then would not have a proper grasp of what the theory was. This is so open to others telling him what the theory was, which brings us then to Sommerfeld again. So maybe Einstein talked with Sommerfeld, and Einstein decided, yeah, what Sommerfeld's saying is probably better than what I said, and Einstein went along with it. But you've got no record of what Einstein is agreeing with or not agreeing with. Sommerfeld, the one adding the footnotes to Einstein's relativity paper in English, with him imposing how it translated and interpreted from the German. So this is how things are getting messed up. A flexible theory where you can keep moving the goalposts all the time, you're just going to mess things up. Next slide, please. This is a quote from the translation of Einstein's paper in English with the footnote, and says if I can read it, my eyes are so bad. Let me take a system of coordinates in which the equations of Newtonian mechanics hold good. And he's got a footnote there for that. And this is the footnote that Sommerfeld puts in, i.e. to the first approximation. So the original German version is, let us take a system of coordinates in which the equations of Newtonian mechanics hold good. There's nothing about it being an approximation. That's the original theory. Nothing about him having a different theory to Newtonian mechanics. It's only Sommerfeld that decides, oh, special relativity is a different theory to Newtonian mechanics, and so I'm going to add this footnote and say that it only connects to Newtonian mechanics as the first approximation. So I'm saying that in the 15 years that special relativity has been changed into a different theory. You've got a theory where it wasn't, the original theory is it was not a different theory to Newtonian mechanics, and after 15 years it became a theory where it was different to Newtonian mechanics, and that's a big change. Next slide, please. So I'll point out, without the footnote, there's no approximation. So what I contend is the original theory was Newtonian mechanics, and there was no approximation. So we got two versions of relativity now: the original theory and Sommerfeld's theory, which has been changed to what was there in the original. Next slide, please. So nowadays, when we talk about the connection between Newtonian physics and special relativity, we talk of Newtonian physics, which I'm using the just abbreviation NP, is an approximation of special relativity, which I write as SR. Especially we say Newtonian physics is a good approximation of special relativity at low speeds, much less than light speed in vacuum, which is C. And that is Sommerfeld's theory, and that's not the original theory. And especially in Sommerfeld's theory, we say Lorentz transformations reduce to Galilean transformations at low speed. And I made a note of a paper there which is pointing out that that's mathematically false, but putting the issue of the mathematics to one side, the claim is Lorentz transformations reduced to Galilean transformations at low speed. And that's the second theory. And that's not the original 1905 German theories paper. In that paper, there's no mention of Galilean transformations. There's no mention of saying there's the Lorentz transformations reduced to Galilean transformations at low speed. What Einstein deals with is only Lorentz transformations and not Galilean transformations. So mathematically, we have something different between the two theories. The original theory is mathematically different to Sommerfeld's theory, which came later. Next slide, please. The claim Lorentz transformations reduced to Galilean transformations was something that came after 1905. And I'm going to do the maths later for that. Next slide, please. If we go to this book again, it points out that Galilean transformations were not named until 1908. So when Einstein was writing in 1905, Galilean transformations did not exist. Einstein was dealing with Lorentz transformations, and he wasn't dealing with Galilean transformations. Next slide, please. Actually, you go to other references and they will give different dates for it. So it's either 1908 or 1911, depending on who you're looking at as to when Galilean transformations came about. Einstein's 1905 paper, Special Relativity, was dealing with Lorentz transformations, not Galilean transformations. Nothing was being said about Galilean transformations and how they were connected to Lorentz transformations. So we have the timeline. Next slide, please. 1905 paper, Einstein's Special Relativity in German, dealing with Lorentz transformations. A bit later, 1908 or 1911, Galilean transformations appear. Those working on relativity decide that Galilean transformations are part of Newtonian physics and not part of special relativity. And that's not decided in 1905. That's something that's happening between 1905 and 1920. So that's when they decide that Lorentz transformations reduce to Galilean transformations at low speed. And hence why you've got the moving goalpost going on. And hence why Sommerfeld put down the approximation as the footnote. The original theory that Einstein was talking about was Newtonian mechanics. He was talking about Lorentz transformations in the context of Newtonian mechanics. But after that came the invention of Galilean transformations, and they decided Galilean transformations were Newtonian physics, and that theory of Galilean transformations is not special relativity. And that's why he puts down Newtonian physics is only an approximation to what Einstein is saying. That is the amendment being made. Next slide, please. So when special relativity is taught, usually the Galilean transformations are talked about first before the Lorentz transformations. That gives the impression, which is actually a false impression, that the Galilean transformations came first, and then working on them came the Lorentz transformations, which is completely false. The reverse happened. Historically, the Lorentz transformations came first, and then the Galilean transformations came. So when it comes to the education system, they're not explaining why, if you got Lorentz transformations, why would you suddenly invent Galilean transformations? They're not explaining that. The education system wants to give the false impression that Galilean transformations are not adequate, so therefore you have to go to a different theory. And that's not historically what happened. So what the education system establishment chooses is the easy option of not explaining the history. Instead, they would like to present a false history. Next slide, please. So, as I pointed out, in the original 1905 paper, German, is not that the Newtonian physics is an approximation at low speeds, and nothing about Lorentz transformations reduced to Galilean transformations at low speeds. And I'm going to do some maths now, I think, and the original theory seems to be based on the following maths. Next slide, please. So we end up with the Pythagorean triangle, and hopefully everybody's familiar with that. Just gasp a bit. So from the Galilean transformation, from the Pythagorean triangle, they decide what the math they seem to use is they decide along the hypotenuse, the speed is c, which is the speed of light c, and along the adjacent side, the speed is v. And then along the opposite side, using Pythagoras' theorem, you have that speed as the square root of c squared minus v squared. So you've got a triangle with speeds. And that seems to be basically what Einstein's relativity is based upon in the original German. It's hidden away in there. Next slide, please. So what they then seem to do is introduce two different time coordinates. You've got the t time and you've got the t prime time. So you introduce that into the equation of the square root of c minus v squared. You multiply that by t, and you say that's equal to c times t prime. And then with a bit of mathematical manipulation, you end up with the time dilation equation. And that seems to be the link between what Einstein's talking about and Newtonian physics. You're suddenly introducing a t time and a t prime time to get a time dilation. That seems to be a fundamental thing what Einstein is doing. In the Newtonian, before what Einstein was doing, you would just have variable speeds, but Einstein decides you're going to have this difference between t time and t prime time. Next slide, please. So I'm not the only person who seems to have noticed this about what Einstein is doing. Glenn Baxter seems to have noticed it as well. And Glenn Baxter, unfortunately, has now passed away. And he used to be talking to us for quite some time about relativity. And when I pointed it out to him about this time thing, he agreed with me, and he said that he'd also noticed this as well. But unfortunately, I've not fully checked out the papers he's given on that. So the fundamental basis of special relativity, and the original special relativity, that is the time dilation equation. Next slide, please. So there's nothing in the original German 1905 paper of Lorentz transformations reduced to Galilean transformations. That was added later. And the original theory was still just dealing with Newtonian physics, with this peculiarity of having two different times instead of there being variable speeds. Next slide, please. And this is what I talk about of moving the goalpost. The theory kept getting amended, and it was amended from a very early stage. When you translate it from German into English, it was amended. And it got people there moving the goalposts. If you play football and you're trying to score a goal, then the goalposts are being moved out of the way so you can't score, which is cheating. Next slide, please. So, when Einstein became famous, this book came out. It was called 100 Authors Against Einstein. And they were arguing that Einstein's relativity was wrong. So the problem becomes, what were they going by? Were they going by the original German, or were they going by the English translation? It's all making a farce of everything. If the theory that you've been criticizing has been amended, and it's not explicitly stated that it was amended. So people are arguing against it, and they're not realizing the theory keeps changing. Next slide, please. And so they point out the theory was just flexible in the sense it kept changing. But some of those changes by Einstein did not seem adopted. For example, in 1905, Einstein seems to say no ether. Then in the 1920s, he seems to be saying there is an ether. And that's in the talk he gave in the 1920, where he seems to be saying there's some sort of ether. So the theory was just flexible up to a point, and sometimes it stopped being flexible. Sometimes the change wasn't allowed. It sort of became rigid sometimes. It's sort of like, oh, you change it, and then suddenly, oh, we're not going to change it anymore. We're going to keep that bit fixed. Next slide, please. So back to the timeline. Next slide, please. So the path was along the lines Einstein theory, 1905 in German, no mention of it being a different theory to Newtonian mechanics. That's in the original German. Einstein, 1915, general relativity. Einstein, 1919, becomes famous, and then there's a drive to translate what Einstein's saying from German into English. Einstein, 1905, special relativity paper translated into English, but now with the changes of opinion that happened between 1905 and 1919. And that's not explicitly being stated to anybody. It's sort of like Sommerfeld. If you go to the translation with Sommerfeld's not saying, oh, I've changed the theory. He's not saying anything like that. It's supposed to be he's presenting the original theory with clarification. And I'm looking at it saying, no, you've changed the theory. So Einstein's theory becomes a different theory to what it was in 1905. Einstein was flexible in his thinking, allowing the theory to be changed, modified, or else didn't properly understand the theory because maybe it was not duly sold to him. Next slide, please. So go back to the example of how the theory is modified with relativistic mass. Next slide, please. This paper, more recent times in 2008, I think it says, has become fairly influential, and it's persuading many people who believe in Einstein's relativity to discard the concept of relativistic mass. And that's where Don Lincoln gets his ideas from. Next slide, please. Now, if you go back to the original paper in 1905, and that's in the German, but still in the English, there is no mention of relativistic mass. It was a concept that was added after 1905. In the 1905 paper, Einstein talks of longitudinal mass and transverse mass, but those concepts seem discarded now for some reason. I don't know, question mark. But he's definitely not talking about relativistic mass. So with the moving goalposts, relativistic mass gets added after 1905. Next slide, please. So the situation is, in 1905, no mention of relativistic mass in the theory. After 1905, relativistic mass gets added to the theory. And now, from about 2008, the people who believe in Einstein's relativity want to modify the theory again by discarding relativistic mass. So basically, with that example, I would have liked gone into a lot more examples of all these changes that keep going on, but this is one of the big ones, that relativistic mass. Relativity is not a properly defined theory. It's just flexible, straight, fluid thinking, where the theory is just an ad hoc mess of conflicting ideas thrown together. The theory was rewritten and continues to be rewritten. Next slide, please. So if we go to the scientific method, this is supposed to be the scientific method. And you can note that you've got a big circle. So it's about going around in ever decreasing circles. And so you sort of, you can pick up from any of these little boxes and go on to the next box. So start with the box, make observations. You kind of like think of interesting questions and you formulate a hypothesis. And then the next box after that is you develop testable predictions and you test your hypothesis. And you've got a choice of routes then. You can either go to develop general theories, or you can go to the route of refine, alter, expand, or reject the hypothesis, and then go back to develop testable predictions. So you just keep going around in this big circle. Next slide, please. And where this scientific method fails is when it gets to this box. And this box is where you refine, alter, expand, or reject hypothesis. So when you get to that box of relativity, you just move the goalposts and don't tell anybody you moved the goalposts. The people moving the goalposts are not telling anyone else, or hardly anyone else, what they did. The process goes around and around, and the goalposts get moved yet again, and so on. The theory becomes ambiguous and unfalsifiable because it keeps getting altered. So this is where the failure in the scientific method is. Relativity has highlighted the scientific method fails. You get to that box and you don't tell anybody that you've refined or altered or expanded or rejected the hypothesis. You're just going to move goalposts. And the problem comes from Einstein, that he has a flexible theory. He's not having a theory that has been fully formulated. He's having a theory that needs amendments to it. So when you're going around in the scientific method process, you're just ending up with people not telling you what they've been doing with the theory. They think they conclude at the end the theory is right, but you don't know exactly what they've done, what amendments they've made to the theory to reach that conclusion. Next slide, please. And as I thought this was worth pointing out. Norton, this is Professor Norton. He's specialist subject is relativity, and one of the things he likes to point out is that the Michelson-Morley experiment can be interpreted from an emission theory of light that contradicts the light postulate. So you don't need to analyze the Michelson-Morley experiment from special relativity. You can just stick with Newtonian physics, basically. You don't have to suddenly introduce the idea that light speed is constant as per Einstein. Well, don't do that. Just carry on with Newtonian physics and analyze it from that. But a lot of people who believe in relativity have not appreciated that, and they think that the Michelson-Morley experiment proves special relativity when it doesn't, because the Michelson-Morley experiment can be interpreted from a different point of view. Next slide, please. So these are my conclusions. I think I cut near the end now. So what we have is the 1905 original theory. It's mistranslated in the 1920s and becomes changed into a different theory. And the methodology of keep moving the goalposts, keep changing things, is making a total mess of things. It is not a properly formed theory and keeps undergoing modifications. Most of those modifications not being explicitly stated. The modifications mean it fails to be properly testable. And not being testable is not a scientific theory. It's not really a scientific theory if you're not properly defining what the theory is. And I think that's my conclusion. Next slide, please. Should say the end. At the end. That's my conclusion. Einstein's relativity is a total mess. At the end. Thank you.
Thank you very much. I'll just get the slides down before for returning. I have to do that first. Let me see. Stop sharing this.
Oh, thank you.
Okay. Well, thank you very much. I must confess, I was a little worried, and I even expressed this to Roger.
Yeah.
That you had 58 slides, and we normally like to give a sort of 50-50 time split between presentation and questions. I said it didn't matter if he went over a little. He kept to the minute, so you've done it very, very well. So thank you for that.
So
And
I've got about an hour for questions.
yeah. Now the only thing is, again, since I was projecting the slides full screen, I had no opportunity to look at some of the comments which were coming in. So if you just give me a quick moment, I'll just see.
I'm getting hot here.
Yeah. Greetings from. Oh, it's a very gentleman. Yeah, from sunny Coral Springs, Florida. Yeah. Okay. Here's one. Maybe just before we start a more general conversation, Roger. He's saying, was there any misunderstanding through translation of the meanings of the words mass, size, and inertia? Presumably means from German.
Oh, I don't think there is. I think that's pretty clear.
Yeah.
At the time, Germany and England were pretty much joined at the hip. They were quite friendly.
He's saying, did one of the translations believe that mass doesn't increase with velocity?
Well, you got the problem. The idea was that after 1905 came the idea of relativistic mass. But if you go back to the original paper, the ideas that Einstein is putting forward are longitudinal and transverse masses, and that's neither anything touched upon now by the education system. Nobody's talking about those ideas anymore. It's just something discarded, and that seems to be discarded in favour of the idea of relativistic mass. So how do you interpret the longitudinal mass and transverse mass? I think those change with velocity, but they're not actually the same as relativistic mass.
Do you see, one might say that you've in a very interesting way, you've sort of shown this demigod to have feet of clay in many respects, and that's fine. But one might say that many of the differences that you've looked at, like adding footnotes and things like that, are not extremely significant in the sense that they don't actually change the theory from something to the opposite. They fiddle around, they change the goalposts, yes. So
it's from Sommerfeld's perspective. He must be able to read it in the German. Oh, he's a German physicist, must be able to. And then he's putting his interpretation on it. So you're translating it from German into English, and he's putting on these extra footnotes to it. But also the paper is not a perfect translating from German into English. He's translated it so that it agrees with his footnotes.
But I think you yourself may have noted this, actually, Roger. Einstein didn't criticize Sommerfeld and say, no, you've traduced my theory.
Well, a lot of the time, you don't get Einstein's opinion on anything. You don't get. I have got no reference of saying whether Einstein thought that was a good translation or he thought it was a bad translation. So I've got no idea what he's agreed with other people on lots of things. I got that note that he didn't agree with the idea of relativistic mass, but that idea got incorporated into relativity, despite him not agreeing with it. So it was other people working on relativity, and they're not necessarily going by what Einstein was saying.
Yes, some of the paper questions coming in, I'm just glancing them at, are basically saying the same thing. One is saying, oh, the mathematics is really the essential thing. The words are just guiding the reader. And if presumably if the equations haven't been changed, There's no major problem.
The equations are a mess. If I did a talk just on the equation, it is a mess to understand what they're supposed to mean. I've done some talks on the maths, and you sort of like Einstein talks about light speed constant, but in the equation, I would say there is the variable light speed in some of the equations he's got down there. So it's sort of like, well, how does what he's saying connect to what he's got in the maths? There's some mess going on there. The maths is a mess as much as the way it's being explained.
Yeah, it might be interesting actually to do another talk on that at some time. Yeah, there's some comments coming in. Oh, most Germans are fluent in English, and they would have been ironed out, and so on.
Yeah, I've talked with some people who know German, and one person who's read it says that the translator who translated it into English had a bias to wanted to interpret it in a certain way. So it's you've got prejudice there of how they want to interpret it.
I mean, for my own part, I haven't really noticed these things or concentrated on them until they were brought to my attention by people like you. But I did notice that the first two postulates that he puts forward, the general relativistic one, and then the speed of light being constant, he expressed it actually in the paper, independent of the speed of the source. Well, that's correct, actually. So that postulate is quite correct, but it becomes changed later on. You know this very well, just using the absolute relativistic principle that there's no preferred frame of reference, and therefore in all the textbooks, really now, if you look at the undergraduate textbooks, they don't quote that second postulates about the speed of light. They say the speed of light is independent of the speed of the source or the speed of the receiver. But that's not what he said.
But that's another thing that is had its goalpost moved. What Einstein says originally about the speed of light is not the same as what is now said. The goalposts have been moved again on that.
Right. We'll soon get to the more detailed discussion. Notice how the title was about mistranslation of Einstein work, and it went to Bill Cosby pretty fast. Don't worry about it. These are. I'd like to.
Yeah, I just pointing out that Bill Cosby and that is this. I try to make sense of that, and it's the male privilege. From a point of view, if you believe in male privilege, then what he's doing was.
I mean, one might say that about old people of that period. As you say yourself, it's a sign of the times. And actually, I was reading something just the other day. I think it might have been in one of our references that said, as Einstein said, a man doesn't understand his theory properly unless he can explain it to a barmaid. Actually, it wasn't Einstein who said that; it was Rutherford. But he said it wouldn't be a sort of a politically correct statement to make nowadays.
I think a lot of these sayings, a lot of these physicists picked up on certain sayings and they sort of repeated it. It was kind of like gossip thing. So one person would say it, and somebody else would say it as well. You use the original source for it.
The issue of sources moving higher. A bit of difficulty in the time dilation equation. Okay, is there anything else we missed? Minkowski space. And somebody talking about Fitzgerald and Lorentz and so on. Okay, well, we might be able to come back to some of those. Right. Okay, we got some more here. You tell me it's an approximate speed. Well, I mean, Franklin, who has said, where is it showing?
So far. Well,
that's what I said.
Yeah. No, I was pointing out that's one of the changes. There was a lot more. And that's
Yeah.
what I consider the most important change, that the theory originally was not saying it was an approximation to Newtonian mechanics. It was just something added later.
Yeah. David Bower is asking, he wonders if Einstein ever spoke or understood English at the time of the translation and so on. I believe he did speak English, but it was quite poor, actually.
It was a long time before he learned English properly.
Yeah.
I think he was giving talks in German, and then it was getting translated into English when he went on his world tours.
There's a famous bit about an audio recording of his explaining the E equals MC squared business, but it's quite not inarticulate, very elementary type of
question,
bad accent.
Yeah, the question becomes: did he fully appreciate the difficulty of translating what he's saying in German into English? So maybe he didn't look into that, and he just allowed other people to do it, and he just relied.
Yeah, here's the thing, Franklin. I mean, like I was saying, I'm not sure if many of these are really a great moment. He says, I don't think the concept that Newtonian mechanics is an approximation to special relativity at low speeds makes any significant difference to the theory. Like if it wasn't explicitly said in the first place, he's saying,
it does. It does make a difference.
You think it does?
In what way? You can change the maths into a different way, kind of like pointed out the time dilation equation, where you've got t time and t prime time. You're sort of like, that if you're sort of like saying it's not an approximation, then what Einstein's introducing is two different times, t time and t prime time. And so, and that you're introducing that instead of having variable speeds, and that's the add-on to Newtonian mechanics, which he's doing. On the other way, in the what I call the mistranslation, he's not doing that. The theory's not doing that. The theory is trying to say that Lorentz transformations is the correct mathematics, and the Galilean transformations is only an approximation. So you've changed the meaning of the mathematics.
I think this is something that might be of interest, as I say, to come back to, because there seem to be some questions which are related to this. Franklin again has just said that, in his opinion, interpreting the light speed as constant in any inertial frame is the greatest misinterpretation. But you see, one might question that. One might say, well, it wasn't explicitly stated that way in the original paper, but it does sort of come out in the wash if you look at it. Okay. I'll just have a look at the private chat, and then maybe I'll bring up some people in the green room who may want to speak. Let's just see what the private chat says. We have been careful about terminology. Roger's thesis about not correct. We cannot call Roger's version of Einstein relativity. Yeah. So I know Nick has some points, and I'm going to bring him up. I hope he gets his camera, or at least his mic, sorted out. Also, German physicists before and after the translation to English treated the 1905 paper in German as relativistic. Beginning in 1916, Einstein began making comments that indicated it. He goes on then, Einstein was recanting on his relativistic views. This is documented in that when... so I'm going through this very quickly. I'm going to ask Nick to come up in a minute and he can speak to this. According to Einstein's shifting views and recanting relativity, I have no comments on the topic of her country, some lady here. And then he goes on again, is correct about changing goalposts. He says, you're right. Yeah, okay. And finally, he says, on the Lorentz transformation, Roger leaves out a very important step, which I explain and give the context for in a paper published by the Institute of Physics, and he gives a reference. My first comments are not focused primarily on relativistic mass. Roger's conclusions are correct. He agrees that. Of any person knows an Einstein state, which might shed further light.
Yeah, you can just keep arguing about these things.
Yeah. Okay.
I mean, if you had a perfect translation of Einstein's relativity from German into English, you could start from that. But what's happened is things have been changed even from that beginning.
So, before inviting people, I'll try to get rid of this comment here to come up. I just maybe finish with one thing at the moment. In a nutshell, if I could try to put you position, Roger. Would you say that the original paper, unadulterated or untranslated, with no additions and so on, was more accurate, less accurate, or equally inaccurate with regard to being a valid theory to explain physical phenomena? In other words, have the translations made matters worse or better with regard to
it's made it worse.
Validity of the theory?
It's made it. There's already I think there's already a mess.
It's already a mess, and so it's
in the original theory, but then you get it translated into English, and then there's another mess added to it, and then you get in all these other things added to it, like relativistic mass. So you're adding more mess to it all the time.
One of the reasons I asked that, by the way, was that I think some people were under the impression that you might have been saying that the original paper is correct, the speculative relative is correct, and it's been misinterpreted. But I think you say you're not saying that.
It's been mistranslated.
Yeah, but even before the mistranslation, the pure pristine theory is still incorrect. Is that your view?
There's still problems with the original theory. You can start arguing over the maths he's presented. I've just dealt with what he's saying. What he's saying hasn't been translated properly into English, and if then you go in by a proper translation of what he's saying, and then you're looking at the maths, and then you're hitting into problems with how does what he's saying then connect with the maths, and so you get in more mess from that direction as well.
Okay, now Nick Percival, I'm going to add you to the stream, but we can't see you. I don't know if you can switch your video. You're also mute, and I think only you can unmute yourself. I hope you can hear us, Nick. I think maybe nothing can be done about your video because you may have a problem with that. But if you could unmute yourself, can't unmute your guest because they chose to mute themselves. He should have said he chose to mute. I hate this plural, but I don't want to get into a sort of a woke discussion about pronouns. Anyway, Nick, I think, has unmuted himself. So we can't see you, Nick, but we can hear you. So you've made a number of points there, which I just read out very, very quickly. I couldn't post them onto the video because they're private comments in the private chat. But we've had a brief discussion about this, and I know you have some particular points that you'd like to raise. Please come in. Are you there, Nick? That's odd. You've unmuted yourself, but we can't hear you. Now, let me see. Because we discussed these points, and actually, I did try to put 1 or 2 points to Roger there, and I wanted like a very quick answer. It was partly to help with some of the points that you and I had been discussing. Like, maybe the misconception that Roger was saying that Einstein's theory was right all along and it's just been introduced. But he isn't saying that. He said it's a mess to start with.
I've got that. Nick saying his microphone's not working.
Oh, okay. So Nick's microphone is not working. So, okay. Well, I'll tell you what we'll do. There are a few other people. We'll get them back. We'll give Nick some time to come in. And if he doesn't succeed in coming in before, I may go back to his comments and just read them out very, very slowly, okay. Roger. Now we have actually Jim has put a few things in as well, which I prefer him to raise himself. So I'll bring Nick down. I'll bring James Keane up if I may. Hello, James. Jim, you have another point that I think you put in the comment.
Thank you, Ian. I'd like to thank Roger for a quite scholarly presentation, which I very much appreciate. He's obviously done a lot of research on this, and I have benefited from his presentation. My first of 3 questions is, are there any personal notes in Einstein's estate, if such a thing exists, perhaps some place where there's an archive of his notes and even those of his wife that might shed further light on the wife's role? That's question one.
Yeah, I've looked into that. There's the Einstein collection being published. Has been published, or I think has been completely published, where they've published all of his notes and that. And I don't really think that it's very clear from there what's going on. And for his wife, the letters to his wife have been published, and there's some letters I think are missing. And his wife had written some physics papers, but that's not been made readily available. So there's still lots of things probably not being put out into the public domain.
Okay, a more general, thank you. A more general question. So, what exactly is relative in special relativity compared to Newtonian physics? For example, there's no variable mass or relativistic mass, what exactly is relative?
I think in Newtonian mechanics, you have the relativity principle, but Einstein is, as it's usually portrayed, he changed it with the idea of the constancy of light speed. And I don't think that interpretation is correct. It's still really the relativity principle in both Newton and Einstein. It's just something that gets messed up in the translation. And as for relativistic mass, well, I think Einstein didn't really like the idea of talking about it as relativistic mass. So it needs to be looked into in what terms did he really want to talk about it, and what are the best terms to talk about it.
So is there anything that is relative in SR?
I gave the equations for the two different types of time, T and T prime, and it seems to be that time is being treated as relative.
Okay.
But they're treating that way instead of treating speed as relative.
Oh, okay. Third and last, perhaps a more fundamental question even yet. With regard to your focus, which is very welcome, on the scientific method, the question is, has special relativity really been tested with data or experiment that special relativity and no other theory predict? In other words, if there's so-called experimental or observational data support for special relativity, it should be some data which no other theory would have any basis to predict. We see that a lot of people will do have explanations for so-called relativistic effects, and so really, my question is, really has special relativity been tested in a way that would exclude any other theory but itself as an explanation, which is the essential point in the scientific method circle that you presented?
My view is that it hasn't been properly tested against other theories.
Bingo. Bingo. I think that's pretty much the most important takeaway point of today, for me anyway.
Yeah.
Actually, many of us could come to similar conclusions from different angles.
Mm-hmm.
Different angles from the one Roger is coming at it from, which is interesting. There's no harm in that. Maybe that would give some further basis, to the conclusion.
Well, thank you, Ian. Yeah, this has been my impression. So basically, according to the scientific method, I would have to conclude, based upon the comments of you gentlemen, that SR has really not been tested by an experiment or observational data which would support it. and reject other theories. It
Yes,
just simply has not been tested. Bingo.
but the people who believe in relativity wouldn't agree with that. And
Why not?
Because the problem is that the theory is not really properly defined. They go, when I show the scientific method, they can go around the loop and they can make their changes to the theory, and then they made their change to the theory, and then they say, "Oh, it's agreed with experiment." They just do their add-ons.
I'll let others ask their questions.
Okay, thanks very much for raising those points, because I think we do have to come at the end of the day to the we have to consider whether the theory is valid and whether it has been experimentally established and indeed uniquely experimentally established. So
the theory is vague, so you can't really prove it or disprove it.
Now, thanks very much, Jim.
Thank you.
I think we're going to bring everybody. Denny has his hand raised, so I'll remove you, Jim. Thank you very much. And I'm just looking at the others. I'm going to bring Denny up now. So, hello, Denny. Please fire away.
Yes. In a paper published in Galilean Electrodynamics by Theodor Theodorsson on July-August issue 1995, here I'll hold it up to the camera. Relativity in Modern Physics. It's pointed out that really all that's known about maximum allowable velocities is that you can't, by electromagnetic means, accelerate beyond the speed of light in ECI. But that doesn't mean you can't accelerate faster than the speed of light because of inertial propulsion, which is ruled out by Newton mechanics, but Gottfried Guschke in a series of books, I'll show his latest one, Inertial Propulsion, you thought you knew everything about physics, has pointed out that inertial propulsion is not electromagnetic in nature, and so it should be possible to go faster than the speed of light if you use inertial propulsion rather than electromagnetic acceleration. And the other thing I wanted to mention is that Ronald R. Hatch, in a 2007 paper in Physics Essays, is entitled A New Theory of Gravity, has shown that both Einstein's special and general theories of relativity are falsified by GPS data. Hatch was the last big GPS guru. He died a couple of years ago. And he had over 30 patents, and one of which was for the Hatch filter, which helped make it so tremendously accurate, the GPS that is. And he maintained till his dying day that, and it's shown in this paper that I mentioned, A New Theory of Gravity, that both general and also special relativity are falsified by hard GPS data. But since he's dead now, they've claimed that that's not true. In fact, that they claim that GPS hard data supports special and general relativity. And that's not true, in my opinion. Yeah. And, well, I was something else I was going to mention, but it slipped my mind. When you get up into your 80s, it's hard to keep a lot of things in your mind at the same time.
You're doing pretty well.
Okay, so the electromagnetic propulsion versus inertial propulsion, that's not something that's being dealt with in the 1905 paper.
No.
So that's what I was concentrating on. And the other
Yeah.
issue, but of course, there's a problem when you sort of bring in gravity to it, which is it's also after 1905, which Einstein was trying to do in 1915, 16, and which he became famous for in 1916 when his math was so say confirmed by Eddington. So those are sort of further on things. But with the GPS data and that, the people who believe that GPS data agrees with relativity are going by the relativistic time equations, and they're saying you've got to use that relativistic factor in the clock adjustments. You've got to use that for the GPS. So that's when they're saying that that agrees with Einstein's relativity. But the problem is, I think really, as Ron Hatch was pointing out, there is a preferred frame, and I forget whether he called it the ECI frame or something. And from the usual interpretation of Einstein's relativity by people is there's no preferred frame. So you've then got the issue of arguing over whether it's a preferred frame or not.
Well, the thing was, Hatch pointed out that inertial mass and gravitational mass behave differently as the velocity increased. For high velocity, the inertial mass is no longer equal to the gravitational mass. But in general relativity, the elevator experiment assumes that inertial mass is always equal to gravitational mass. So it's just it's based on a thought experiment with faulty premises.
That's probably
that might be the control freaks.
okay. That's probably tied into the relativistic mass problem, because when they taught me about relativistic mass when I was doing a relativity a long time ago in physics course 30, 40 years ago, they taught about relativistic mass in relativity. And my way of thinking was, well, if you've got an object like a spaceship and it's going at a very fast speed, then its mass is going to increase. And so what's the effect of gravity on that? And that's not something they really talk about in special relativity course. They don't consider the gravity of the gravity effect on relativistic mass. So if a spaceship goes really, really fast and its relativistic mass is really big, then surely it should turn into a black hole. And so, well, that then violates all the other things that special relativity is talking about, because then gravity, which they're ignoring, becomes significant. You can't ignore gravity anymore if an object suddenly goes so fast it turns into a black hole. But I think that was the problem they were trying to face when Don Lincoln and all the others talk about there's no relativistic mass, because they don't want a spaceship to go so fast that it turns into a black hole. So that's why they're discarding the idea of relativistic mass.
Yes, well, at Stanford, it said that one of the professors there, when he teaches special relativity, he teaches that there's only just a rest mass. There's no relativistic mass.
That's the new thing.
And the relativistic mass comes out of the fact that you assume that the acceleration is by electromagnetic means.
Yeah.
And,
That's new. That's not in the 1905 paper, and it's not when Don Lincoln, not when Bartlett and that added the idea of relativistic mass to special relativity.
So maybe just to clarify a couple of points which have been coming out of that this discussion just now. Number one, with regard to the practical operation of GPS, they do adjust the clocks on the satellites relative to the Earth, depending upon the relative speeds and also the gravitational potential. Yeah. Now, that's explained conventionally by time dilation. So what's your view about that? I mean, is there time dilation, or is that a lot of nonsense? Or is there some physical effect occurring in these atomic clocks? And similarly, they explain with regard to these particle accelerators that they get a variation in mass with speed. What would be your explanation of that?
Well, first of all, about the experimental stuff. David DeHirsler's documentary, he was talking to an experimental physicist, and who does the accelerators, and that person was saying there wasn't relativistic mass. So that's saying different. I agree that when they teach you relativity, they would say that accelerators have relativistic mass in it. But when you talk to an actual experimental physicist, they might say something different. And what was the other issue?
The other one was the working of GPS every day in your motor car.
The way I look at it, the maths for it, they've done the adjustments. They've got the maths, and they're looking at all that maths for how they analyze the data, and they're saying, oh, that's special relative. Well, that's special and general relativity of Einstein. So that's Einstein's relativity. But you also then got the problem on top of it of, is there a preferred frame or not? And my view is there is a preferred frame. And I think Ron Hatt's view is that there is a preferred frame. And I think he was calling it the ECI frame, Earth-centered frame. And so from his point of view, if I'm putting it correctly, his point of view, there's a preferred frame. And so this claim from relativity that there's no preferred frame is false. But people who believe in relativity, some of them believe that relativity has a preferred frame. So it's more moving goalposts.
Yeah, many of us, I mean, dare I say it, for my own part, and maybe Nick Percival, if I'm speaking for him for the moment in his absence, we would say, I think, that there's a physical effect in these atomic clocks with regard to the frequency of vibration, and that's what's actually causing the variation between this ECI frame, which we could, if you want to call it a preferred frame, you could do so. So you perceive of these time differences as well, would you, Roger, as being physical effects of maybe atomic vibration?
In the maths I presented with the Pythagorean triangle, it sort of what they've done is they've made a t time and a t prime time, so they got two different times. And so if you're using that math, you're trying to then to get the clocks to agree with that. But then if you've got a preferred frame of that, then one frame is going to be faster and one frame is going to be slower, but not both faster and slower.
I'd like to come back to that, actually, because we're running out of time. I want to make sure that I bring people like Harry in, and maybe give Nick an opportunity of coming in. But Harvey has a specific point on that very Pythagorean triangle and so on. So I'm going to bring Harvey up now. He didn't realize that all he had to do is lift his arm. He thought it was like a sort of a statement for some electronic facility. So Harvey, if you'd like to make that point about the right angle triangle and so on, please feel free to do so.
Yes. Can you all hear me?
We can hear you.
Okay, good. Roger, thank you for the presentation. I really appreciate it. You brought up this slide here, this slide.
I think I had the times ran different. I think it might.
Well, if you this is the speed of light. I'm trying to do this backwards. There you go, going this way. And here would be the first source. So it's hard for me to do this backwards.
Yeah.
Sorry. Okay. Yeah. I'm not too.
You're not doing too badly.
Yeah, but anyway, what happens is the light speed never changes regardless of what the velocity of the source is, which is assumed emits the light. But if you follow the equation, you will get the time dilation formula, which is invalid because V can be anything and the speed of the hypotenuse never changes. You know what I mean? The velocity of the speed of light across the hypotenuse doesn't change. It's like not only moving the goalposts, there are goalposts that actually emit the light. And we're talking about a time delay theory. It's a time delay theory. I got a paper I'm writing right now, and I'm just trying to adjust one paragraph, and I'll put it on Vixra and let Ian Cohen know about it, and he can get in contact with you, Roger, or whatever. And I'll let you, or if you want, I can email it to you and have you be a reviewer, so to speak, before I post it on Vixra, because I don't want it to go away in the future. Okay. So anyway, that's the thing. It doesn't matter what the velocity is. it's not going to have any effect. So therefore, it's an invalid physical interpretation. As okay, that's all I had to say.
Do you
I
accept
really,
that, Roger? It's maybe, we don't have time to go into very great detail.
Well,
We can maybe study the paper later, but just a quick reaction.
It's a problem. What do they mean by light speed constancy? So you've got in that triangle, you've got two uses of the c. That's constant light speed. You've got two uses of light speed c in that triangle. You got it along the hypotenuse, and you got it along the what's that side up front up the side.
the horizontal right there.
The vertical. So you're using it twice, and so you're putting an interpretation on what the light speed constancy is supposed to be.
Yeah, and this diagram actually is derived from the light clock experiment. You know, where the beam's going up and down, but as you're moving, it has a long I can't do it backwards, sorry, but anyway, you got it. So anyway, I can send this to you if that's acceptable.
Okay.
But I do appreciate your talking and breaking up the different things.
When I talked to Glenn Baxter, he was agreeing with me what he was saying about that sort of thing. Unfortunately, he's passed away now. I got his papers and I'm still looking through them to see what he's saying about it.
Well, it might be interesting for you to at least exchange that. I mean, for my part, that's one way of looking at it, Harvey. I tend to dispense with t and t prime. I just use one universal time. And then I would have, as Roger did, the square root of c squared minus v squared, or perhaps c squared plus v squared. That's what I would have.
So what's important, and then I'll let it go. What it is see, as the light is going from the source to the observer, which there's the observer. You get a time delay. There's a time delay. So the time delay that is supposed in the rocket emission of the lights, time t naught and time t naught plus some delta time, is different. Okay, and then when he gets right here, he submits. This is the vertical emission of light. So as it's vertically emitted, everybody agrees nothing changes on that time. So he gets a blip here, the acceptance of the first light, which is over here, and the second light, which is up here. That's this time delay right here. The way the experiment is set up, that's this time delay. So what the observer gets is this time delay right here. And what the rocket ship time delay is right here, because see, oh boy, it's backwards. But anyway, it's hard. The observer does not even get the first signal until after the hypotenuse time delay, which is, I can't find it there because I'm looking backwards. Sorry about this. Okay. Well, anyway, you'll see that it's just the time delays. So the time's not warping or anything. It's just describing the time delay of the source between the two the emission signals, the birth and the death by Dr. Dowdy, and then also the time delay of the first receipt of the first signal of the observer and the second signal of the observer. And what's wrong is you're using the Pythagorean theorem. So therefore you get the infinity if the sources was V plus C, but this is not V plus C. This is constancy of C, which is wrong. Thank you.
Okay, just before letting you go, Harvey, very, very quickly, if you could, do you conceive that if the receiver is moving, you get C plus or minus V?
If the receiver
or is it constant C? So in other words, you were talking there about the source moving, the rocket, and it's emitting signals. Well, if you have an observer who's moving, and let's say the source is constant,
well, okay, so what I would describe that is if you have the source moving and it's emitting, it's going to emit the signal at C plus V. So the center of the circle moves with the C plus V coordinate. And then
so if the source moves, you consider it a C plus V. Okay, yes. Well, there's a long discussion there, and we'd have to have it. And I think maybe some of us disagree. But anyway, if you want to contact me or you want to send the paper to Roger, we can take this out further. Now, we're going to give Nick a bit more time, but if in about 5 minutes he hasn't come in, I'm going to have to read out his statements. But before doing that, thanks very much, Harvey, for those points. I'd like to bring you down and maybe invite Harry, who hasn't raised his hand, but I'm sure he'll have a lot to say about this. So, if I could take the liberty of bringing you in, Harry, you're the other person in the green room who hasn't spoken, and I'd like your general view about the importance of looking at the whole
Okay.
business.
All right. There's not much time left.
Go ahead.
There's not much time left. So I want to say I agree with the conclusions. I'm not sure I agree with the goalpost moving. I think it's Einstein never really fixed the goalpost to any particular place. I think that's the problem that's the fundamental problem. And so it's kind of, because it was never really put in concrete by Einstein at the beginning, other people had to sort of figure out what, had their interpretations put on it. Okay, here's the book, Einstein's 1912 book, Manuscript on Relativity. Have you ever seen this book, Roger?
Yeah. I've
he
seen
never
it.
finished this book.
Sorry? Yeah.
My point is, he never finished this book. This was supposed to be the definitive exposition of special relativity, and he never finished it. Okay, I think that's a problem right there. All right. Okay, Einstein never definitively wrote what his theory of special relativity is.
Yeah.
Okay, so that's a problem.
Yeah.
I
think
the other thing is, okay, I'm not finished. I want to talk about Pauli, Wolfgang Pauli. Here's his book, 1921, I think.
Wolfgang Pauli.
Okay, so by the time you're talking about the translations, Pauli had already written what appears to be a definitive version of special relativity in this book. And there were other books. I don't have copies of the other books, but this is the original German book. Okay. So other people had pretty much defined what relativity was. Okay. Although Einstein was supposed to be the author, other people really were defining what it was by 1920.
Yeah.
Okay, so if there's a difference in the goalposts, maybe it's a difference because different people have different opinions about it. And I didn't even bring in Minkowski, who significantly changed a lot of things. So it was a question of, do we pay attention to Einstein 1905, Einstein 1907, Einstein 1910, Einstein 1911? They're all papers where he wrote different things. Okay, and then Minkowski's paper, which was, I forget, 1908 maybe. Okay, and so that's kind of a different theory for Einstein's theory. So now you have the question of which theory is the theory of relativity. Is it Einstein 1905? Is it Minkowski 1908? I'm not sure whether that's the right date. But anyway, Minkowski's version, or the attempt by people like Pauli in this book.
You got Lorentz version as well. And
and there were other people who wrote books, like I said, Van Lowe, I think, wrote a book. There was there were papers coming out, that were had different ideas about relativity. Gilbert and Lewis wrote a paper which introduced the light clock that Harvey just mentioned. And I don't really think that's really relativity. Okay, I have a problem with that light clock. And so what you have is you have a lot of different theories of relativity. Okay, that's my opinion. And the reason I think, you understand what I'm saying? So my interpretation. Well, I don't see it as much as moving goalposts. I see it as everybody has a different opinion as to where the goalpost ought to be.
What's moving the goalpost?
Okay, well, I can agree with you if you want to take it, but I say it's because people have different opinions about where the goalposts are. Okay, so even today, you start off with your thing about people are still disagreeing about the meaning of relativistic mass. So that means there's still a disagreement. Okay, there's not a definitive interpretation. They're still doing that. And so I think it's more people have different opinions. People are different textbooks may say different things. I'm not, I haven't read all the textbooks on relativity, but I don't think they're all uniformly the same. I don't think they're all uniformly the same. You have differences.
Yeah.
Books were written at
You're breaking up now. He's
Textbook in
breaking
the
up.
1960s, textbook in the place.
Okay, you just started to break up a
Am I
little.
correct about that? So the question is all right, I'm sorry, I'm talking too fast and too loud. So I think the issue is
you're breaking up.
when about special relativity. Okay, so when you're saying special relativity is wrong or whatever, there's so many different versions of it, which is wrong. Okay, this version here. What books are we referring to when we say special relativity is wrong?
We'll go back
They're not going to tell us.
Paper.
Well, the problem is this original paper was modified by papers in 1907 and 1909 and 1910. So, but he never did this. This is about as close as you can come to being his definitive statement of what relativity is.
Yeah.
But he never published this and never finished it. Okay. And this is supposed to be the definitive opinion, the definitive Einstein's theory, but never got finished. Only, and if you look through this, you'll see he's marked out. He wrote a bunch of stuff and then he crossed it out. Okay. And all this does is just reproduces unfinished manuscript. So he never finished his theory. It's an unfinished theory. Okay, so that's a problem.
Yeah. I think all that is really tied into Einstein's quest for the unified field theory, because with the special relativity, it's supposed to deal with electromagnetism, and general relativity deals with gravity. And he was, with the unified field theory, he was trying to combine gravity and electromagnetism. So he was still carrying on for a very long time trying to change things around. And that's where he's flexible. He is moving the goalpost himself. He's making changes all the time. So he's not got a definitive theory. He's got something very flexible, and he's going to keep changing things. And that's where you go with Einstein. He's on his quest to get a fixed theory, but he never really gets there, and he dies.
But I mean, one might say that's not something to blame him for. I mean, from the point of view of, say, somebody who accepts the basis of Einstein's theory, unlike maybe many of us, including myself. But one might say, well, he's modifying it in the light of new evidence and of new ideas. John Maynard Keynes said, when the facts change, I change my views. What do you do? So it could be said that what he's doing is developing his ideas.
But the trouble is with that, it's not being explicitly stated. You sort of like, you've got a theory, and then he changes his views, and you haven't got the reason why he changed it. And you've got all these changes happening, and you're not getting a reason for why he's changing things, and that's happening all the time.
So the change is a bit of a problem, but also if you just forget about all these developments and changes, just go back to the original. Let's take the 1905 paper on its own merits for the moment and forget about the developments. You would sort of say, would you, that it's really the original paper in German in the Annalen der Physik that should be looked at. It's a bit like the Bible. You better look at the Old Testament in Hebrew. You better look at the New Testament in Greek or something, because all these translations can lead to various denominations have different ideas.
That's the way I'm looking at it. You can translate the Bible in different ways.
Okay,
and
you get all
treating Einstein's theory of relativity as a whole.
Pardon me for disagreeing, Ian.
Okay, go ahead.
Pardon me for disagreeing, but I looked at the 1905 paper, the 1907 paper, the 1910 paper, the 1911 paper, his 1912 manuscript, Okay, and also these books, he's wrote this popular book on general relativity and special relativity. I forget. Okay, there's that. There's the infield Einstein book on the evolution of physics. Okay, you need to look at all of those if you want to get basically what Einstein's theory is. You can't look at the 1905 paper and say, "Oh, that's the theory." No, it's not. And people, it's just not. Now the question is, okay, what is the theory, and what is the definitive statement of the theory? Now, some experts say, go to some textbook. Okay, go to this textbook. And you go, what? I don't have a copy of that textbook, and so, so the question is, what is the definitive theory? If you're disputing Einstein's theory, what is the definitive statement of the theory that you're attempting to refute? Most people go to the 1905 paper.
Yeah.
And well, it's full of mistakes.
Yeah.
Well, the problem is maybe there's no definitive theory because it's developing. And he died, as you say, Roger, in 1955, and he was still advancing these new ideas. So maybe it's an amorphous theory, that you cannot deal with.
Yeah, that's right. So what happened though is if you go for
the question is,
Sorry,
yeah. You're breaking up a little, Harry.
My point is, all right. The point is, what is needed is an agreement on what is the definitive statement that mainstream thinks is the official theory of relativity. They'll answer by, well, here's a textbook. Okay, that's fine, but the problem is that textbook may not be what all relativist physicists or everybody agrees to as what the definitive theory is. So it just becomes this problem of what Roger was saying is moving the goalpost, because you need to have, everybody needs to know what the theory is, and this is the book that describes it. Okay, and it's not really possible, from what I can say, to get them to actually say this is the definitive theory. Because if they do, then the theory becomes subject to experimental test and refutation.
Yeah, that's probably it. The problem is that when you talk to people who believe in Einstein's relativity, such as the educators, that they're not going to admit that there's been changes to the theory. They're just going to say this is as per what Einstein was saying. So they're not even recognizing things have changed with it.
Well, if I may, before wrapping up, I'd like to give Nick Percival one more opportunity of coming in, or if necessary, just maybe try to highlight. So thanks very much, Harry. If that's all right, I'll bring you down now. Sorry, you've raised some very interesting points, which I think we're going to have to come back to, because it's a debate as to what is the real Holy Writ and development of it and so on. But so let me just see, is Nick's microphone working? Are you there, Nick? No, I don't think so. I think he can hear us. But if we just spend a minute or two just seeing what he said, technical problems. We have to be careful about terminology. If Roger's thesis about Einstein's views were mistranslated is correct, then we cannot call Roger's version of Einstein's 1905 paper relativity. However, in the 15 years before the alleged mistranslation, the literature treats Einstein's paper as relativistic. Also, German physicists before and after the translation to English treated the 1905 papers in German as relativistic. Beginning in 1916, Einstein began making comments that indicated that Einstein was recanting on his relativistic views and reacting to criticism about the relativistic aspect of his original 1905 paper. This is well documented in C.S. Unsekern, Current Science, Volume 89, Number 12, 2008-2005. While Academia read Einstein for his relativity, Academia ignored Einstein's shifting views and recanting of relativity. I have no comments on the topic of her contributions. Oh, that's Malevy, his wife, first wife, etc. Roger was correct about changing goalposts as relativity changed in 1905. In fact, it's worse than that, as there are two separate categories of SR that are contradictory. One SR describes what happens physically, and 2SR describes just what is observed and not about physical effects. Yeah, this is like things like length contraction. Some relativists adhere to both contradictory interpretations. So that's more like having two different goals and switching from goal A to B when you've shown that theory A leads to a contradiction and vice versa. On the Lorentz transformation, Roger leaves out a very important step, which I explain and give the context in a paper published by the Institute of Physics. My first comments are not focused primarily on relativistic mass. Roger's conclusions are correct. So after all the contradictions there, sorry to go through all this very quickly. He still has technical problems to speak. I have no working microphone. Okay, so that's it. I think we may come back to a lot of this in discussion, but just maybe before I close, have you any brief reply to all that long criticism, which in the end he agrees with you, but I think he disagrees with some of the roots there.
I wasn't covering everything about Einstein's relativity. I was basically concentrating on trying to make sense of Einstein's paper of 1905, which is the first paper on Einstein's relativity, and I'm pointing out that it's not been translated properly. So it's been modified in the English translation, and if you want to, you can go and add on all the other extra problems on top of that. But that's what I was pointing out, and I was giving one example of the relativistic mass as being a problem where things keep changing all the time by what people are saying. Have you run out? Is this finished by then?
No, I've just taken myself down momentarily because
yes, I saw. I thought we ran out.
I'll take you down and close it.
I thought we ran out of time. Okay.
No. We have run out of time, but look, if we go for 5 minutes extra, it's not the end of the world. I just want you to be happy with that.
So
we could obviously spend another hour talking about this. That's impossible.
So I was pointing out the problem of the moving goalposts on the first paper of 1905. That if you're trying to start from that, you're looking at the English translation, and things have already moved on from what was being said in the German.
Okay. So, if you're happy to leave it at that, I'll probably just put my head above the parapet and trying to summarize, and not in detail, but in finishing. So I'll bring you down. Thank you, Roger. Right. So Roger has kept very much the time in the talk itself, and the questions actually. We have to stop the discussion now, but we could go on for a long more. And I think there's a lot of meat there for further discussion and digestion. But I'd like to thank Roger very much for taking the trouble of producing those very comprehensive slides and speaking to them and speaking quickly, but yet in a comprehensible and comprehensive way, because it is a subject. I'm interested in it. I have mixed feelings about it. I'll have to look into it in more detail. He has at least prompted me to do that. As to the importance of the evolution of Einstein's views, or the views as interpreted by others, as in regard to the translations from the original language. There are subtle things, maybe in the different language and so on. I'm not convinced that many of these elements are very significant. In other words, I have come across scientific and philosophical ideas which were actually the actual opposite, 180 degrees out from what their normal interpretation is. I don't think we have anything like that here. I think what the textbooks are doing, they have slightly different nuances on the theory, which can be important if you're looking into it in very great detail. But I think the general theory, which is adumbrated, is as so, and that gives rise to your own analysis and conclusions. I mean, I've come to the conclusion that basically the theory is erroneous, and you might say, which theory? Well, I say the generality of the theory. And if I'm relying unduly on the 1905 paper, okay, there was evolution of that, and I'm not sure if the evolution improved upon it at all. But I'd like to thank Roger very much for having raised this whole conception. It's another way of looking at things. his terminology using the goalpost, you may balk at that, but it's one way of looking at it. And I think it's got us all thinking, certainly. And we've got a lot of comments here, which unfortunately I had to rush through very quickly, but because I was putting the slides up, and also we had a number of people in the green room. We had a problem with Nick because he actually had the most comments to make, and his microphone wasn't working today. So that's Murphy's law. But we'll continue with that. Actually, we're not escaping from, or Roger's not escaping from us, rather, because he will be back in a number of weeks. I probably to speak on longitudinal radiation, I think, or Tesla waves, perhaps. Just keep an eye on the announcements. And I think we'll have a bit of a break from not from presentation. We're hoping to have another presentation in a fortnight, but it may be on analysis of some videos of maybe one of the interesting physicists who didn't want to speak directly because English isn't his first tongue. So again, just keep an eye on the emails, and if you have any comments at all, just please feel free to contact us and make them, and we can deal with them then. So I'm going to end the broadcast now, 5 or 6 minutes late. I'd like to thank all of you in the Facebook and YouTube media for your contributions. You've made a lot of very interesting contributions, and I hope you found it of some interest. I think today's lecture was actually very interesting, looking at everything from this point of view. And I'd like to thank our regulars in the green room, all of you, for having talked and raised all these important points. And actually, if any of you have other points, for example, Nick, that he would have raised had the time been available, or had the technology not broken down, please feel free to do that, and we'll either deal with it jointly or we'll forward your comments to Roger. So last but not least, I'd like to thank Roger once again for his very concise explanation. He's saying goodbye. Thank you again, Roger. We are indebted to you. I'm going to end the broadcast now. So good day to everybody, wherever you are on the globe.